short answer is yes. If our current understanding of the laws of gravitation in the universe is correct, dark matter must exist. The long answer is much more complex than this, and I'll try to explain it briefly in this video. So, dark matter is a type of matter that doesn't emit light and was introduced back in the 1930s, some say even earlier, to address the anomalies found in the astronomical observations. Since then, our understanding of the problem has improved a lot, but the discrepancies in observations still hold. The conclusion is that there is simply not enough visible mass in the universe to explain the high velocity of stars and galaxies around us. And this means that if there isn't anything funny happening to the laws of gravity, then there must be lots of matter which we cannot see.
This is advanced darkness.
Now, adding to the hints coming from astronomical observations, today dark matter is also a requirement in our current best model of the universe, the lambda-cold dark matter, which has been remarkably successful at describing observations such as the cosmic microwave background, which tell us that approximately 5 out of 6 parts of the universe mass are in the form of dark matter. Finally, we also have huge simulations of the universe, such as the recent Illustris, which you can see behind me, that tell us that all of the structure that we see around us would not have formed hadn't it been for dark matter, which adds to the already extensive list of hints pointing to the ubiquity of this elusive type of matter. Despite all of the arguments in favor of its existence, from the experimental point of view, dark matter is still a no-show. And this is not because of a lack of trying. In fact, for several decades we have been investing a lot of time and effort into trying to find any signature of dark matter beyond the gravity effects that I described in the beginning of this video.
Are a very particular set of skills. Skills I've acquired over a very long career.
Now, one of the main ways in which experimental groups search for dark matter is by building huge vessels with cold noble gases, installing them deep underground, shielded from any background noise, and using them to look for nuclear recoils due to interactions with dark matter particles. Other experimental groups look beyond these vessels to the universe around us, and they attempt to detect indirect signals of dark matter, such as byproducts of dark matter annihilation, or effects of dark matter interactions in large astrophysical targets, such as the Sun. On another front, particle physicists working at large colliders, such as the Large Hadron Collider at CERN, are on the lookout for any missing energy that could potentially result from dark matter particles that are created in collisions and are not seen by the conventional particle detectors.
I will look for you. I will find you.
Despite all of the effort, and in some cases ingenuity, dedicated to the search for a convincing dark matter signal, experiments have so far come out empty-handed. And while the lack of success of experimental efforts has put some favorite candidates under considerable stress, we have barely scratched the surface when it comes to the plethora of possibilities that have been proposed to address the dark matter problem. Because of all of this, and also due to its relevance in other fields such as particle physics, we can expect that the dark matter puzzle will be in the limelight of the physics stage for years to come, with exciting new experiments planned for the near future, which will hopefully shed light on the nature of dark matter. If you enjoyed the video, like and subscribe. And don't forget, you ask CENTRAnswers.